Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
Let's talk about fog. Now, fog is really just a cloud on the ground. In other videos, we've talked a little bit about what clouds are, how clouds form. Basically, they are water droplets, water in the form of a liquid, suspended in the air, floating around there. Well, this happens up in the sky, and we have the recipe for the cloud. If you remember that cloud, we're going to need two ingredients. We're going to need humidity, and we're going to need a condensation nuclei. Center. Good. And that condensation center, the condensation nuclei can be dust or salt or anything else like that. And then the process to get to where we're going, we have to make colder. Okay, so we talked about making colder by making the air go up. When the air parcel rises, it gets bigger. As it gets bigger, it expands. As it expands, the temperature decreases. Pressure, volume, temperature, all of that. Okay, so can we do the same thing? Can we have humid air and condensation nuclei in there and then make it colder, but on the ground? Of course we can. There's two different ways. There's a number of different ways that we see this, but we're going to focus on two of them. The first type that I want to talk about is advection fog. Advection fog. Okay, so what is advection, first of all, right? So it sounds kind of familiar. We've talked about something similar to this. Advection is just movement from side to side. Okay, now convection, we'll put that over here. That's what we see when we're going up and down. So convection is going to be going up or going down. Advection is just movement, but going from side to side. Okay, so what do we need to do? Well, we need to create an environment where we meet the recipes, where we get our humidity, where we get our condensation nuclei, and then we need to move it to someplace colder. Now, the one place that we see this here in California a lot is going to be along our coasts. Okay? So if we could look at the entire Pacific Ocean, right, we're going to have, we'll put in the islands of Hawaii right out there, right, and then we're going to have our California coast, and we have the Gulf of Alaska coming down, and my map's going to be terrible, right, and it comes down along the California coast, right, so we're going to say that's the California coast. So what happens along the California coast? What happens out here over Hawaii? Okay, now, it wasn't that long ago that I made my first trip ever to Hawaii. And so if you haven't been there yet, don't give up hope. The time still can come. Okay, what do we know about Hawaii? I'll tell you, it is very hot. Okay, very, well, we'll say warm. Okay, so, 85, 90, that's warm these days. Okay, so very warm, and boy, is it humid out here because, remember, it's lower latitude. It's going to be warmer. Okay. And because of latitude, it's going to be warmer. It's surrounded by water. So obviously we're going to have a lot of humidity in the air. Okay, so what are we getting? Well, we've got the ocean. So we've got a lot of the salt particles that are floating around there. We've got our condensation nuclei. We've got our humidity. Okay, so we're going to have our two ingredients, humidity and salt particles suspended in the air. Bam, we have all of our ingredients. Now we just need to make it colder. Well, fortunately for us, and I'm looking for a nice thick wide old blue pen. There we go. Fortunately for us, we have the California current. Now what's that California current do? It actually comes from the Gulf of Alaska. Not Arkansas, Alaska. Good, the Gulf of Alaska, and it brings nice cold water down along our coast. Okay, so what does that do? Well, here's the deal. We've talked a little bit about circulation, and we know that we have some predominant winds that are taking this humid and salt particle air and blowing it towards the coast. Now, in the summertime, it's going to be a little bit warmer. Okay, and so that contrast that we see between this air and the water temperature right here along the Gulf of Alaska is going to be greatest in the summertime. Okay, so we're really going to be looking at our summer pattern. What do we see along our coast when this humid and salt particles come along our coast? Well, it gets over this cold water that's coming down and it creates that fog. Okay, so our California coastal fog is an example of this advection fog. Okay. Now, there's one other type of fog that we want to, so moving air from one spot, it gets its conditions, moves to another spot, gets the final part of that cloud formation. One other type of cloud that I want to talk about is radiation fog. Radiation fog. Okay, now I know this green just doesn't come through very clearly, so we'll go to the next fog. What is radiation? Well, that's just going to be moving temperature from a surface, right? So we've talked a little bit about this, and a lot of times we talk about the heat moving from the ground up into the air. Doesn't always work that way. Sometimes what happens is the ground can get very cold. Now, here in the Central Valley of California, this is the type of fog that we see here in the Central Valley. Coastal, we're going to have our advection fog. Here we get our radiation fog because during the day, we get our warmer temperatures. So let's talk about the daytime. And maybe we should make that in red. Good. During the day, it is warm, and we've got a lot of agricultural land, and we've got a lot of rivers, and we've got the delta, and we've got all sorts of humidity. And we've lived here for a little while at least. We know that there's always a lot of dust in the air or pollutants or any other types of things that can happen. Now, that's going to be in our daytime. Now, once we get to, and then the sun is coming down. And yeah, the sun is coming down. It's making it warm here on the surface. But during certain times of the year, it gets cold and it gets cold fast. We're moving into that more. Okay, so let's talk a little bit about night. At night, we still have that same air. We have our humidity and we have our dust. You guys see where I'm going with this, right? It's the ingredients that we need. However, the land gets cold. When the land gets cold, then the heat in this overlying air, what color should we do air? Here, we'll do it in a lighter blue. This overlying air, this air mass that has the humidity and has the dust, that air starts to get colder. It gets down to its dew point temperature, and boom, there we go. Now we have that fog. Okay, there are a few other types of fog between advection fog and radiation fog. These are our two that we see around here most often. Okay, there's a few other. There's called upslope and steam fog, precipitation fog. But a fog is just a cloud on the ground. Okay, humidity, condensation nuclei, make it colder somehow. You might be moving it to a different place. You might be moving it from somewhere where we make the conditions and the conditions just change. Okay, I want to show you one more picture that I took on a recent trip. Okay, so this is the Wind River, and this is going to be one of the tributaries to the Columbia River. So it's just on the Washington side of the border between Oregon and Washington. This water is flowing down off of I think it's Mount St. Helens. It's coming down out of the mountains. It's like snow melt coming down. However, this day was warm and humid. Okay? And what that does is you can see that that cold water is making that air right above there a little bit colder, and it's making that fog form on top of the water. Just another type of that radiation fog that we were talking about earlier. So sure, it might have to do with the land getting colder. It might be really, really cold air on a warm or cold water on a warm, humid day.